It all started with how slow can you go? How slow can you go e-foiling or pump foiling to be efficient, have ludicrous lift? I'm on Axis, and Axis's largest wing is the 1310. And I want it bigger. Sabfoil makes a Leviathan 1750, which is absolutely monstrous, and I wanted that for Axis without having to completely change over to Sabfoil. Wanted to try it out. So, against all better judgment, against all common sense, I decided to make the Axis Leviathan 1750 for the red Axis fuselage. Here it is. Frickin' huge. It's over 5 feet tall, and it's a monster. And it works. Needs improvement, but it works. It's a good first start. It all starts in CAD, where I used images of the Sabfoil Leviathan in Fusion 360 to lay out the basic shape, get the overall dimensions, but of course that doesn't get me the airfoil cross-section. There is a commonly used hydrofoil cross-section from some random paper that shows up on the foil zone forums. It's a very popular hydrofoil cross-section that was lofted down the length. Of course, with Axis and the Axis Red, why I like the Axis Red fuselage is that it's got this massive, chonky connection to the foil that a lot of other wings and systems don't have. And I like the width here. I like the fact that it is beefy. I like the fact that it is torsionally stable. And I wanted this. But of course, the drawback and the reason that Axis moved from Axis Red to Axis Black is the fact, I don't know if I can really see it, I might show you in CAD, but you end up with this sort of like B-2 bomber bulge across the bottom where you need some meat for the screws and everything. And so all of that has to kind of, it makes this bulgy, thick cross-section that I imagine is difficult to design around. And of course, it's not a perfect foil section there. So the lift and whatever else is, who knows, you might just not be getting as much lift. So, but I like Axis Red, I own Axis Red, so we're stuck with Axis Red. The overall build method is, this is full of 3D print. So there is a PETG core, looks like a model aircraft in here, and of course it's printed in 20 centimeter sections because that's as tall as my printer was, or as tall as I really wanted to kind of print before something fell over or broke. Also in here are 2 carbon fiber tube stringers, one nice big one all the way across the front here because I figured the weakest point is right where the fuselage meets and the whole thing just wants to fold up and dump you and slice you to bits. So there's a big carbon fiber rod all the way through there, and then 1 carbon fiber rod per side back a little bit, and that helped align all of the sections to get epoxied together. I chose PETG not because it's the strongest or anything, but because it is epoxy compatible, and I figured I would have a good bonding between the carbon fiber layers and the PETG. So that's the basics. Now, of course, it becomes a pain in the ass as you're gluing up the PETG sections with the carbon fiber tubes and everything. You don't want any twist. You don't want this wing to be different from this wing in any way, shape, or form. So you're trying to align that. And I ended up using some offcuts from a previous job, just some wooden pucks, and I hot glued them onto the PETG after epoxying the sections together, so that I ended up with a relatively solid section of 3D printed nonsense that once it cured up, once the epoxy all cured up with the carbon fiber tubes and whatnot, became pretty solid and was able to be worked with for the carbon fiber application. This is my first carbon fiber job, and it is very different to work with than working with fiberglass and epoxy resin. The biggest difference is that carbon fiber really wants to be straight. Doesn't want to conform around your edge. So it's not, I was trying to build this thing sort of like building a surfboard, where you do a wrap around and then you cut, and you wrap from the other side and you cut, and then you hot coat and sand and all of that. That's sort of the approach I took, because I didn't really want to do the proper way. Well, didn't really want to, wasn't able in any way, shape, or form to make large aluminum molds and cast this the proper way. There's videos out there on YouTube on how to do this, on how companies manufacture these in the real world, and it's all pre-preg and layup and perfectly cut out sections and volumetric analysis, so that when you smush and glue, it comes out perfect with no voids or anything like that. The other problem, of course, is how to make this shape perfect, where the fuselage meets the wing. And I did that with 3D modeling and printing blanks for this. And then I also just took an old fuselage, coated in wax for mold release, and cast the old fuselage right in there. I'll get into the details of that. The main idea is that this pocket becomes a flat surface, so that you have perfect alignment when you're using it as a plug. Kind of messed that up. There's a nasty hole there. I choked. I got worried that the fuselage wasn't going to release, and I pulled it a little too early. I should have let it cure up and fight with it after it was cured. So, lessons learned on mold release. How efficient is it? Is it faster? Is it slower? Does it suck? What's going on? So we got the Axis 1310, which is a big wing. Not a lot of people like it for pumping. It needs a little speed. It's not the easiest thing to dock launch. But it is okay on my e-foil. So the Axis 1310 draws about 500 watts, and I will be doing about 14 kilometers an hour minimum speed. You can go a little slower than that, but you're on the edge of stall the whole time and it gets a bit twitchy. So 500 watts, 14 kilometers an hour, Axis 1310. The Axis Sabfoil Leviathan 1750, well, comes out a little better. It's 400 watts for about 12.5 kilometers per hour. So it's slower and also less power. Let's talk about efficiency per kilometer. The Axis 1310, 500 watts, 14 kilometers per hour, works out to 35 watts per kilometer per hour. Axis Sabfoil 1750, ludicrous wing, comes out at 32 watts per kilometer per hour. Lower being better. We need to talk about how it rides, because with these super wide, super high aspect ratio wings, you lose the playfulness. Standing on this thing, it both feels like a very stable platform, but when you get it off center and you fight to bring it back, it's a bit of a noodle. You can feel the whole thing flex. This is why I want to add more carbon fiber to this whole thing, one more coat. There's definitely a penalty for having a wing this big. my sort of goal, my ridiculous corner of the sport that I'd like to occupy, is trying to get very low watts per kilometer regardless of speed. The lower you can go in speed, everything, the drag comes down of the mast, the drag of the motor housing, and so on and so forth. For first effort, it is nominally better. I wouldn't call it better in many aspects other than watts per kilometer than a professionally made wing, but it works, and it hasn't snapped in half. And once I get one more layer on here, I'm going to go out and torture test it. There we are. Hope you enjoyed it. It's been a while. Anyway, see you next time.